All right, so the first thing we're doing is we're reading this about how to solve world problems. Trigonometry can be used on a daily basis in the workplace, since trigonometry means triangle measures, 3 angle measures. Any profession that deals with measurement deals with trigonometry as well. Carpenters, construction workers, and engineers, for example, must possess a thorough understanding of trigonometry. In word problems, the formulas remain the same. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So first we're going to talk about angles of elevation. The angle of elevation is always measured from the ground up. Think of it as an elevator that only goes up. It's always inside the triangle. In the diagram at the left, X marks the angle of elevation from the top of the tree seen from the point on the ground. You can think of an angle of elevation in relation to the movement of your eye. You are looking straight ahead. You must elevate your eye to see the top of the tree. The angle of depression is always outside the triangle. Outside the triangle. It is never inside the triangle. In the diagram at the left, X marks the angle of depression of a boat seen at sea from the top of the lighthouse. You can think of the angle of depression in relation to the movement of your eye. You are standing at the top of the lighthouse and you are looking straight ahead. You must lower your eyes to see the boat in the water. Let's turn it over and look at the back. As seen in the above diagrams of angle depression, the dark black horizontal line is parallel to CA and triangle ABC. This forms what are called alternate interior angles, which are equal in measure. So X also equals angle BAC. See how it's two parallel lines cut by a transversal, alternate interior angles? Okay. The angle of depression and the angle of elevation equal the same thing. So what do we do with this angle of depression that's outside the triangle? There are two possible ways to use our angle of depression to obtain an angle inside the triangle. One, find the angle adjacent next door to the angle, okay, which is inside the triangle. So see how we did this? We know this has to equal 90. So 35 minus 90 gives us 55. Or we know from alternate interior angles that these are both 35. You can use either way. Once you've created your diagram, the word problems are solved in exactly the same manner as the problems we discussed for the lessons for finding sides of a triangle. Okay, so now we're going to use this information to be able to do our word problems. All right, so we are going to do a couple of these problems. We're going to start with number 1. So for all of these, you're going to want to draw a picture. Okay? A boy flying a kite lets out 300 feet of string, which makes the angle of the ground 38 degrees. Assuming that the string is straight, how high above the ground is the kite? So I've got the string for the kite. Here's the kite. Okay? I want to know how high it is above the ground. Here's the ground. I know the string was let out for 300 feet. So where is the string? Is it the black line, the green line, or the blue line? Black. And it says that my angle for the ground is 38 degrees. And what am I trying to find? Am I trying to find the distance from where I am to where the kite is, or the height of the kite? Okay, so we'll call this our x. Okay, so this is the angle that I'm dealing with. Ooh. Okay, so this is the angle that I'm dealing with. What is x to that angle? Opposite, adjacent, or hypotenuse? Opposite. And what is 300? Let's look at it again. What's 300? There we go. Because that's 90 degrees. Okay, so if I'm looking at and I'm dealing with opposite and hypotenuse, am I using sine, cosine, or tangent? Sine, because sine is opposite. So I'm doing the sine of 38 equals the opposite over the hypotenuse. Okay, I'm going to do this one as if you had your trigonometric ratios worksheet in front of you. Okay, so sine of 38, so I'm looking for 38, and then I go over to sine, that's 0.6157. That's 0.6517. So I'm going to change this to 0.6157 over 1 equals x over 300. And then I'm going to cross multiply. So then I go 300 times 0.6157. And I get 184.71. So right there, that's how high I'm off the ground. Okay? So you can just do it with plugging in tan into your calculator, but I wanted you to be able to understand both ways. 0.6157 over 1 equals x over 100, and this is 184.71. So 184.71 feet. So if I do it on the calculator, if I said the sine, so if I did 300 times the sine of 38, I get the same thing. I get 0.698 instead of 0.718. But if we round up, we get 0.7, right? Yeah. So let's just leave it 184.7. Okay. Let's look at number 3. So unfortunately, this is going to disappear because I'm recording. And we're going to move down to number 3. Straight road to the top of a hill is 2,500 feet long and makes an angle of 17 with the horizon. Find the height of the hill. 12. What did I say? 17. Oh gosh, 12. Thank you. Okay, so we've got a road that's on top of it, so it's going up a hill. That's 2,500 feet long. It makes an angle with the horizon of 12. I want to know how high up that hill is.
How do you know when you do the setting or the elevation?
All of these, I believe, are for elevation. Yep. Okay. So, what is x to 12? Good. What is 2,500 to it? Okay. So remember, we've got our SOHCAHTOA. Which one deals with opposite and hypotenuse? Sine. Sin. So sine of 12 equals the opposite over the hypotenuse. Okay. Again, I'm going to do it using the trigonometric ratios paper. So that means I'm going to go for 12, look at sine. I get 0.2079 over 1 equals x over 2,500. So I'm going to cross multiply this, so that means 0.2079 times 2,500 equals x. So I get out my handy dandy calculator. 0.2079 times 2,500 gives me 519.75. And what is that, feet? Feet. When you plug that in the calculator, do you get approximately the same thing?
No. Yeah.
So if I get 2,500 sine 12, yeah, it says 519.779. So approximately. All right. What do you think? Should we do one more? Yes.
Do a hard one.
Yeah.
Do the hardest one. Yeah, do the harder one. Do the hardest.
I don't think any of them are hard.
Oh my gosh, but I mean, like, that would be difficult for us. You know, it's gonna be difficult for us.
I don't know. They're all about the same.
You know what you said.
7. Okay. Okay. So we've got a damsel in distress is being held captive in a tower. Her knight in shining armor is on the ground below with a ladder. When the knight stands 15 feet from the base of the tower and looks up at his precious damsel, the angle of elevation to her window is 60 degrees. How long does the ladder have to be? Okay, what would I draw? So she's in a tower. So the first thing you draw, does a tower go sideways? Is it laying on the ground? No, it's what? Straight up and down. That's my tower. Okay? You can draw a fancy tower if you want. If the knight stands 15 feet on the ground, would that be the slanted part, or that would be going at a 90-degree angle outwards? So here's my 90 degree. Here he is. Here's my little prince. Okay? He's 15 feet away. Okay, and so the ladder would go straight up and down right here? It would be angled. That's what I want to find, my ladder. And it says the angle of elevation is 60. Okay? We good so far? How I'm doing, because I think the drawing's the hardest part. Okay. What's 15 to 60? Opposite, adjacent, or hypotenuse? What is x? Okay, so I'm going to write out SOHCAHTOA again. Which one uses adjacent and hypotenuse? Cosine. So remember, I write cosine 60 equals adjacent, which is what number? Over what's my hypotenuse? X. Okay. And as requested, said, can we do it the calculator way? So we're going to cross multiply. X cosine 60 equals 15. But how do I get the cosine to the other side? I want x by itself. Divide by cosine 60. So x equals, all right, let's do this in our calculator now. 15 divided by cosine 60 gives me 30. And if I was going to do this on my trig functions, I just do 15 divided by, I look up cosine of 60. It's 5.5. So I divide it by 0.5 and I get 30. Okay. So I have done 3 out of 10. That's the picture you use. So you don't